Another linear method of laying out simple curves is chord bisection. This method will be employing many formulas for every iteration made. Learn the process here in Engineering Surveys. Similar with perpendicular offsets, this method will be using the long chord. It is required to know the midpoint of the chord and the distance the curve is offsetted, thus regular intervals is not necessary. By learning the midpoint of the curve, one has to compute for the distance of the curve from the long chord, and that is determined by comparing the radius reduced by the distance from the origin to the midpoint. There is a right triangle generated which can identify the distance. By using the given radius and known angle, which is actually half of delta, side OB is taken using cosine, so the resulting formula that we can get will be CD is equal to R less R cosine half of delta, which can then be simplified as R times 1 minus cosine of half of delta. For the second iteration, the same concept will be applied. This time the curve can be taken as half of the original curve, so we need to compute for the half curve's long chord. Take note that the angle of the half curve is delta upon 2. So like the previous derivation, the distance of the curve from the new long chord is taken as C1 D1 equals to R times 1 minus cosine of delta all over 4. With the whole long chord suggesting that CD is equal to R minus cosine of half of delta, and half the curve will be resulting to C1 D1, which is equal to R times 1 minus cosine of 1/4 of delta, we can have a conclusion that the next iterations will be of the same formula but with changes in the proportions of delta. Take the sample computation. Trace a curve for R given as 100 meters and the central angle delta as 45 degrees using bisection of chord for 3 iterations. We start with finding the long chord using the given radius and central angle. With the long chord known as 76.54 meters, take the midpoint and locate the offset with the formula CD is equal to R times 1 minus cosine of half of delta. And by plugging the given values, CD is taken as 7.6120. The first iteration will be taking a new long chord with the same formula, giving the value LC1, which is 39.02 meters, and then locate the curve with the distance CD, which is taken as 1.9215. Do the same procedure for the second iteration, where a new long chord is calculated to identify the midpoint, and then distance CD is computed with a fraction of the central angle, and that would be 0.4815. To complete the third iteration, solve for the partial long chord once more. Identify the midpoint and compute for CD3 to locate the curve. CD3 is computed as 0.1205.